Welcome to Chakka International. I'm Nilamarjana speaking. This is related to civil service main examination subject electrical engineering 8085 microprocessor opcode fetch machine cycle. The graphical representation of different operation of a microprocessor is carried out by a timing diagram of 8085 microprocessor. The timing diagram is important. One can design the circuit as per the requirement. 80 timing diagram based on three cycles: T state, machine cycle, and instruction cycle. T state is equal to 1 clock period. Instruction cycle, the sequence operation carried by the microprocessor to execute instruction. Machine cycle, the one cycle required to move 1 byte of data in or out of the microprocessor. There are 7 types of machine cycle: opcode fetch, memory read, memory write, IO read, IO write, acknowledgement interaction, and bus idle. And here the state, opcode fetch 40 or 60, memory read 3T, or memory write 3T, IO read 3T, IO write 3T, acknowledgement 60 or 12T, bus idle 2 or 3T. This is the sample presentation of fetch cycle. Fetch operation, first byte instruction known as opcode, and the instruction may be 1 byte, 2 byte, 3 byte, 1 byte. So this is the fetch cycle, to the execution cycle, and this is send address to memory. Memory get opcode from the memory location, and transfer opcode to memory location. This diagram is important. This diagram most important because I have written everything here. Signal T1, T2, T4, clock cycle, A4 higher order data, then lower order AD0 to AD7, then active high ALE, then IOM and S1 signal, RT and WR. Here everything mentioned at what step, what option will go at high or come, low at every state, T1, T2, T3, T4. So machine cycle is the time required to complete one operation. Here the cross pattern, this pattern indicates bus waveform. This cross indicates the new byte added to the bytes. It is mentioned in the side, no need to repeat. 8087 line contain lower bit address, 88 to 80 line contain higher bit address. ALA high indicate that multiply 8087 act as a lower byte only. ALA high indicates multiplex 87 act on the lower byte. IOM low, memory location being accessed. IOM S1 S2. Here in a phase cycle, IOM 0, S1 S2 1. The back side, AD and WR determine the direction data flow between microprocessor and load microprocessor and IO device of memory location. Here the what is T1, T2, T3, T4. In T1 state, 8085 places the contents of the program counter on the address bus. The higher order byte of PC is placed in A8 to 815 lines. Lower byte of PC is placed in AD0 to AD7 lines, which stays only on during T1 state. The microprocessor activate address latch enable, which is used to latch the lower order byte of the address in the external latch before it disappears. In T1 8085 sends status signal to IOM S1 S2. IOM specify whether it is memory or IO operation. S1 status specify whether it is read or write operation. S1 S2 together indicate read, write, opcode fetch, machine cycle operation. What is the halt state? Or in opcode, the fetch machine cycle signal IOM 0, S1 is equal to 0, S2 S0 is equal to in fetch machine cycle IOM by 0, S1 1, S0 1. In step 2, in T2 lower order address disappears from the AD0 AD7 line However, A0 to A7 remains available as they were last during T1. In T2, 8085 sends RD signal low to enable the addressed memory location. Memory device then places the content of addressed memory location on the data bus AD0 to AD7. In step T3, the 8085 loads the data from the data bus in its instruction register and register RD to high, which disables the memory device. In T4, microprocessor decodes the opcode and on the basis of instruction received, it decides whether to enter T5 or to enter T1 of the next machine cycle of 8085 microprocessor. 1 byte instruction, those operated on 8-bit data are executed in T4. For example, MOV1, AND, ADB, INL. For 1 byte instruction which operate on 8-bit data is all available in internal memory of 8085, that is registers. With this, the print is complete. If you like it, subscribe, put the bell icon. Thank you.